the art of the tweetcart. So tweetcarts are little animations like this that fit inside of a tweet. So the right is the animation, the left is all the code that you need to generate this animation. A couple other examples, Boxpeak is a really great show. Wandersong is a fun game. Shout out to both of those. And you can even do this with making games. 2D Array somehow fit an entire playable game of Tetris in these 280 characters. Alright, so this is the same animation as this is the same animation you saw a moment ago, but this time it's broken down so it's readable. So right now we're at 658 characters. Our goal is to reduce that down to be small enough to fit within a tweet. So first off, we don't need any of these comments. We already know what everything does, so we can just get rid of those. But before we do that, actually, let's do a quick walkthrough of it. So when it launches, it just moves the camera. This changes where all the draw operations are relative to. So we just move it so that the ship will be at the center of the space. We want to clear the screen and set the random seed every frame. This is used because the stars in the background are drawn in random places. If we change the seed, then the stars will move around. And we do this every frame because we want them to be in the same space. If we don't set the seed, the stars will change every frame. We call circfill to draw the stars and the ray that the alien is moving, and then we draw the ship. We're printing a cat to draw the alien here, and then we go through a loop to draw the lights and draw the human. So if we want to have any hope of fitting this in a tweet, we got to get rid of all the comments, and we also want to get rid of the indentation. So we're already saved almost 200 right there. Something I notice here, we create variables for all of these things, which makes it really easy to read, but we don't, it takes up a whole lot of space. So let's just copy paste the X into the X, the Y into the Y, and then these two are just constant numbers. So we don't even need those at all. And we're at 414, which is better, but we still have a lot to go. Something we can do here is improve the flow of control. So we have init and draw, but we don't really need those exactly there. Anything you put outside of any function will just get executed before the cart runs. So I can just get rid of init, and this will still run at the very start. I can replace the draw function with a goto. This is something you may have heard. If you went to school something recently like me, this is something you know you're never supposed to do. But we're gonna do it. We're gonna do it here because it saves some valuable space. So this is not right. That's because it's actually in an infinite loop right now. What draw did is it drew it once a frame. Now it does all of this, and then it immediately does all of it again forever. So we want to add something called flip here. This just waits until the end of the next frame to start drawing again. We still have a lot of tokens to save. So something else we can do here is we can replace a lot of these function calls with variables. So let's say I can do a equals circfill, and then anytime I call a, anytime I call circfill, I can replace it with the letter a to save more tokens. This is something you might not know. Oh, I noticed I also have the same thing with next color here. So I can save more space just by, let's see if this works on my first try. Nice. So I can save more tokens by getting rid of all that because it's used there. And let's see if I didn't mess up. I did mess up because I do need this variable to be here, but it doesn't have to be such a long variable. So I can change its name from next color to just make it shorter. Okay, looking good. We only have about 60 more characters we need to save. So let's see what we can do just by getting rid of more white space. Functions like srand and clears, clear screen, we only ever use them once. So we wouldn't get any benefit out of it from making it into a variable here. Circfill is very long, so each time we're using a instead of circfill, we're saving 7 whole characters. Another thing, this is something you'd have to look into some of the documentation to know, but a quick way you can do print a. You can also just do question mark a, and that'll save some characters. So we can replace these print statements with question marks, and it'll save some valuable characters. And we're almost there. We're at 305 out of 380. So something I would do at this point is just try and get rid of all the white space that I can figure out how to do. So I can't get rid of this new line because then this becomes a rectfill camera, which it thinks is one variable. But I can get rid of this line because it doesn't think that this is one longer variable. I can get rid of this space after these do statements, and that still works. These question mark statements have to be on their own line, or else it just won't go through. And we're at 292, so we're almost there. We just need to take a little bit more savings. I can probably do that by, what functions are we using a lot? We're using cosine 3 times here. Oh, time is also a long function. Something we can do is, so we can print out the time, but you can also just print out the letter t, parentheses, and it's a shorthand way to write time. So replace time with t, t, t. That will save 9 more characters. We're still at 297. So let's see if we can assign that to a variable to save any more. So let's say z equals t. And now we don't need the parentheses. So I'm at 297 now. If I do this, I can replace 1, 2, 3, and I'm still at 297. So that didn't save anything. So it's not really worth keeping unless I use time one other time, which it doesn't look like I do. I use cosine 3 times here. So that might be able to be somewhere we can save space. So c equals cos. So this statement is 5 characters. Each time we replace a cosine with a c, we're saving 2 characters. So we replace it 3 times. We save 2 characters 3 times, which makes it okay that we're using 5 characters here. This is the kind of math that you have to figure out to get good at this, but it's also really easy because you always have a character count here. I can get rid of these spaces. I can get rid of that space. Boop. And I think I can move that first, and I think I might be able to fit it all in now. $286, $285, $284. Oh, I can get rid of these spaces. So if you have basically get rid of any white space, don't worry about making it readable because making it readable makes it not fit. Here we are at 279 characters, so it fits within a tweet. Let's go ahead and tweet that out right now, and that'll be the end of this presentation. Bad news, everyone. This cat counts as an emoji, which takes up an extra space. So we have to find one more to get rid of. Which shouldn't be that bad. I say as I draw a blank, looking for unnecessary white space. This went perfect in my practice run. Live on Siege in front of tens of people, probably many tens. Oh, I have a time here, so I could just replace it with T, and there we go. All right, so that'll be a tweet sent out live, and thank you all for coming to my 2 talks. Hope you stick around for my next one in 10 minutes.
I absolutely love that. That is great. That's my old style of debugging. I haven't had to compress code into anything that small in a long, long time. That was a lot of fun to watch in action. I hope everyone else enjoyed it nearly as much as I did. Oh, everyone wanted you to preserve the cat. There were a lot of calls in.
The cat's not going away. The cat is the necessary part.
Cats getting in the middle of your programming has become the story of COVID year. So we can understand how that's going. All right. Looking for questions and chat. That was a really fun presentation. I really enjoyed seeing the coding move like that, and I really love the outcome of it as well.